Okay, welcome to Applied Mathematics at Northeastern State University. This is our video number 5, which talk about chapter 6. We're talking about statistics right now. It belongs to part of the part 2, statistics and probability. Okay, continuing from chapter 5. This chapter we talk about some application of statistics, basically doing some calculations. Okay. Now in chapter 5, I told you guys that whenever you see a result of statistics, you should have a reasonable doubt because the result may not be 100% reliable. But on the other hand, statistics is really useful, especially if you have a huge amount of data at hand, right? If you just look at the individual data point, data number, right, you don't really get a whole picture of your data, right? Now, in some cases, it may not be even possible to go through the whole data set as human beings, right? In those cases, statistics is kind of essential because you can get some overall information about this data set, okay, which can be really useful. To do that, we need to introduce some useful concepts to use in statistics so that we can use them to calculate something out of our data, and we can use them to represent our data, okay? Now let's talk about them one by one. Let's start from the mean, okay? The first concept is called mean, okay? So it is basically a simple arithmetic average, okay? The meaning is very simple. Let's say you have these 5 data points, 4, 4, 6, 7, and 12, okay? The way to calculate the mean is simply adding those 5 numbers together and divided by the number you have, which is 5 in this case. If you do this calculation, you got 6.6. That's simply the definition of mean. We could give an official definition, and we could use a formula to talk about a general case, but I think we don't need that, right? This is good enough. Now, the second concept we want to talk about is called median, okay? This is kind of similar to the concept mean, but it's a little bit different, okay? Now, why do we need this concept, okay? Let's say, suppose we have, maybe let me first introduce what the meaning of that concept, okay? So median is simply like this, okay? You count those points from the lowest or the highest, okay? And you stop at the middle. You have odd number of points here, like this case, you stop right at the middle. So this means for this stat, okay, the median is simply 6 because it's right at the middle. Now let's say you have 6 instead of 5 points. Let's say you have 4, 4, 5, 6, 7, and 12. To calculate the median of this point, you take the 2 middle numbers and take the average of the 2 middle numbers. So the median for this set would be 5.5, exactly at the middle of 5 and 6. Okay. Now, as you see, right, the median of a data set and the mean of the data set may give you different numbers. Okay. Now, what's the point to have this second concept? Okay. The point is sometimes our data set may be very uneven. Okay. May have a huge difference. For example, let's talk about the salary in the country. Let's suppose that 80% of people has really low salary, only 20% has high salary. So in terms of data set, we may say that we have the salary we have is like 10,000, 20,000, and 30,000, and 40,000. And then let's say for the last 20% people, they have really high, they have 1 million, let's say. Okay, now if you calculate the mean of the set, right, which means you add them together, right, basically 10K plus 20K plus 30K plus 40K plus 1,000K, right? 1,000K is a million, right? And then divided by 5, right? This first 4 numbers give you 100K. So plus 1,000K is like 1,100K, right? And divided by 5, you got a pretty decent number. like a 1100K. So it's like a 220K. Okay. So if you just look at this mean of this set, right? It's a huge number. You would you get a conclusion that this country, people in this country are pretty rich because they have a decent income, like $220,000. But actually, it's not the case because 80% of people actually has pretty low income, right? Now, if you use median though, you count it 1, 2, 3. This is the middle number. So the mean of this data set is this, but the median is going to be 30,000. Okay. Now that gives you a more realistic count, right? You see, half of people in the country earn less than this number, right? That's pretty low, right? Compared with the top 20%. So if you look at the point is this: you can calculate both the mean and the median. If these two are very different from each other, this tells you something about this data set you have. It tells you there's a huge range in the data set, okay? And in this case, tells you that most people in this country is pretty poor. That makes sense? Okay, I mean, there's actually another concept that actually kind of relate to that, okay? It's called the range of the data set, okay? In calculating the range, it's very simple, okay? You just take the median, let's say you have this data set, right? You just take the highest value, subtract the lowest value, so the range of this set is just 8, okay? That tells you the range, okay? Again, in some cases, you may have a really large range of your data set. In some cases, you may have a really small range, okay? Now you can compare this range with the median of the data set. In this case, it's 6.6, right? So you can see that from there, you can see how separate, how big the like the range you have in this data set. Okay, now another one is called mode. Okay, by definition, mode simply tells you the number that's mostly appeared in this data set. In this case, where all these 3 numbers appear only once and 4 appear twice. So the mode of this set is basically 4. Okay, it's just simple like that. Okay, next, let's talk about another very useful number 5, standard deviation. So what does that mean? Okay, again, let me look at a specific data set. Okay, let's say you have this data set: 7, 8, 10, 9, 6, and 5. Okay, we have 6 numbers here. Now you can easily calculate the mean of this data set by adding those numbers together and divide by 6. And if you do the calculation, you get the 7.5. That's the mean of the data set. Okay. Now sometimes people are interested in how each data is deviated from the mean value. Okay. Like 7, the deviation of 7 and the mean is 0.5, right? They're different by 0.5. And the second number is also 0.5, et cetera, et cetera. And not only that, sometimes people are interested in the mean deviation, okay, of the data set. That means on average, how different a specific data point is different from the mean value, okay? The average deviation, the average difference, okay? Now, how do you calculate that, okay? Based on the simple idea of the average, right? Naively, you would think like that, right? Take every number and subtract the mean from it. That's because that's the deviation, right? Add all the deviation together, divide by 6, right? Divide the number of the data you have, right? Let's try this, okay? You divide 7 minus, let's use 7 minus 7.5 plus 8 minus 7.5, okay? Plus 10 minus 7.5, okay? Plus 9 minus 7.5 plus 6 minus 7.5. I'm sorry, I'm kind of running out. Let me write it this way, okay? 5 minus 7.5, okay? So each one of these term is the deviation of the specific data points from the mean value of the data set, okay? We have 6 of them. Okay, add them together, divided by 6. Okay. Now, amazingly, okay, you can repeat this. Try to do this calculation. Amazingly, if you do this, you get 0. Exactly 0. And if you try another set of data, whatever set you do, okay, you can calculate the mean and then do this kind of average of deviation. You always get 0. It's almost like works like a magic. Okay, actually, as a matter of fact, you can tease your friends by showing this kind of trick to the friend. Your friend may feel like, wow, how could it be, right? Now, what's the point? Okay, the point is this. If you think about the basic definition mean, right? By definition, mean is a number that exactly kind of like the middle of your data set, okay? So this way, if you make those deviations, so, half of the deviations will be negative because they're going to be below the mean, and half of them are going to be above. And they will cancel each other exactly, so you get 0. Okay? So this way of doing calculation of the average deviation does not work. Okay? So this is we're trying to calculate the average deviation here. Deviation from the mean. Okay? This does not work. Okay, it does not work. Now, how do you do it? It turns out you do have a way to do it. Okay, instead of considering the deviations themselves, you can consider the square of them. Okay, so let me just use another page because we're running out of space. So if you see 7, 8, 10, 9, 6, 5, and then we calculate the average. The mean is 7.5. Instead of calculating deviation directly, we would do the derivation and then take square. Okay. Again, this is time consuming, but I want to write it explicitly for you so you can see it. Okay. Again, I have to write this term at the very beginning. And then you make square of them and then divide it by the number of data you have, 6, and then take square root. And the reason you take the square root is because you have squared here, so here, right? So you take square root so it can kind of go back to the original data point. Okay. Now this is about almost like the definition of the standard deviation we talk about. Okay. However, in reality, we have to subtract 1 here. Okay. Instead of using 6 of number we have, we subtract 1. Okay. This factor -1 come from some more sophisticated concerns about the sample versus population. Okay, if you have a population, you don't have to subtract 1. But if you have just a sample, if you want to do a statistic for the sample, you do need to have to subtract 1. Okay, so most time we work with samples instead of whole population. So that's why we need to subtract 1 here. Okay, and this is our definition of standard deviation. Okay, it tells you on average how different is a data point from your mean of the data set on average. I hope this makes sense to you. Okay. Now, at last, okay, the last concept I want to talk about is called something called normal distribution. Okay. So what is the distribution? Okay. Firstly, let's talk about distribution. Okay. Suppose you have a bunch of data. It goes from from 0 to 100, maybe like a result of a test from 0 to 100%, right? And then you have a bunch of people that take this test, right? Certainly, that means for any given score, you have a certain number of people that getting this score, right? Let's say there's like a lot of people taking this test, like 100 or 1,000 people, right? Now you could draw a curve based on what we talked about from last lecture, like a line chart. It kind of tell you, like you have people getting the score at any given number of people, right? Number of people. This is what we call the distribution, okay? You connect them like a line. Basically, at any given possible value of the score, you have a certain number of people get it. Okay, this is what we call the distribution. Now, normal distribution is something kind of special. It means that whenever you get a distribution, it's a bell shape. Okay, you get a bell shape of distribution like this. In general, it can go from minus infinity to infinity, okay, out of the possible values. But it always falls, the average always falls right at the middle of zero, or zero value. This is the number of events or number of people in that case. And this is the possible values you have for this data set. Okay? Now, the normal distribution here is the bell shape. The average always at zero, and then the mean and the median are all at zero. Okay, and then the mode is at zero as well. Okay, everything's here at the peak is at here. Okay, now if you talk about 0 to 100, you actually have a shift of the. Actually, if you have a lot of people taking this test, it's going to be at like here, roughly like 50. This is, I mean, anyway, this is called normal distribution. Why is normal? It turns out you have a lot of people, a lot of random events happening. Okay, and then you want to do statistics for the random events. It turns out that mathematically you get a bell shape. Okay, you get a normal distribution. Okay, now, like this case, if you have a lot of people taking the test, on average, a lot of people, then on average, most possible result they get is going to be like 50% out of the test, out of 100. Okay, so this is what we call normal distribution. Okay, so normal distribution has a very interesting property. If you look at the bell shape and then the average here, if you go one standard deviation from the average, we call it 1 sigma, and then you go 2 standard deviation, we call it 2 sigma, okay? And then 3, we call it 3 sigma, okay? Now, it turns out that within 1 sigma, okay, you got already like 68% of events, okay? So that means if this thing happens, 68% is gonna have this value, or 68% of the population will get a score within 1 sigma of the average, okay? Now, if you want to talk about 2 sigma, it's become 95% within 2 sigma. Okay? Now, within 3 sigma, it goes to like 98%. Okay? So basically, everything falls within a few sigmas, a few standard deviations away from the mean. That means this distribution has a pretty narrow range, okay? Because most event falls in that. Okay? And that is all I want to talk about for today. Okay, let me make one last comment. Okay, this sign here, the symbol is called sigma. Okay, pronounced like sigma. It is a Greek letter. Okay, it is not the 6. Okay, they look very similar, but they're not the same thing. Now, if you see it in print, you'll see better. Okay. This is for significant standard deviation, as we talk about. Okay, finally, let's talk about the question for bonus point. Okay, write in your email one example that have for a same data set, whatever it is, right? Maybe the result of a test or whatever. Tell me an example you had that has a very different mean and median. Okay? The value for the mean of the data set and the value for the median of the data set is very different. There's a huge difference. Okay, just tell me that and you get your bonus point. Thank you for watching this video. Again, I think this one's pretty short. I'll see you in the next video.